Have you ever noticed that when a vinyl record spins faster, the music suddenly gets higher and faster? Today, I'm going to explain how vinyl records produce sound using waves, vibrations, and frequency. What is sound? Sound is a vibration that travels through the air in waves. These waves move from a vibrating object, like a speaker, then into our ears. One important property of sound is frequency, which is measured in hertz or Hz. Higher frequency means a higher pitch, while a lower frequency means a lower pitch. For example, a high-pitched sound has waves that vibrate more frequently compared to a lower-pitched one. Everything starts as sound waves created by voices and instruments. These sound waves are then converted into electrical signals that control the cutting needle. The cutting needle cuts through the lacquer, creating tiny grooves. These grooves contain tiny small patterns that match the original sound waves that we hear. The grooves are very small and microscopic that you can't see them on a real vinyl. In this model, I tried to get it as close as I could to an actual groove. For example, loud sounds create larger movements in the groove, while quiet sounds create smaller movements. High-pitched sound creates tighter patterns, while low-pitched sound creates wider patterns. These grooves contain information about frequency, pitch, loudness, and timbre. As the record spins, the stylus follows the groove. The groove causes the stylus to vibrate, creating sound. These vibrations are converted into electrical signals. The speakers then vibrate and create sound waves that travel into our ears. Speaker cone resonates with the signal and pushes air molecules back and forth. Humans can normally hear frequencies between 20 and 2000 hertz. That is known as the audible range. Vinyl records are often designed to produce sound within this range. Using a frequency analyzer, I measured the frequency in hertz. Bass sounds contain lower frequencies, while high-pitched sounds contain higher frequencies. This allows us to observe sound scientifically. Halfway through the video, the speed of the record is increased. Because the groove moves under the stylus faster, the stylus vibrates more frequently. Using the frequency app that I have showed before, this is the data that I have collected. It shows how the song starts off around the 70 frequency, and then it does a jump almost to 81 as we switch and increase the speed of the song. So in conclusion, vinyl records store sound as physical grooves that contain information about frequency, pitch, loudness, and timbre. As the stylus follows the grooves, the vibrations are then converted into sound waves, like shown here, and changing the speed of the record changes the pitch and the frequency, showing how sound waves can be manipulated and changed as we hear them. That's it. Thank you.